All right, everybody. My name is Philip Daramendi. This is Pat Hez. Thomas Slavinover. We've got the Powerhouse. We initially wanted to make it an idea that could be used for the home. Kind of not have to plug anything in due to absolute laziness, and no wires, just complete wireless power through a house. We did look up, and it was, various websites said that there wasn't actually any sort of physical damage that could be, acquired due to this wireless power in a house. So we thought it might be a good idea. Then we started actually working on the wireless power, and we ran into some snags, but eventually we got it going. I'm going to pass it off here to Pat.
All right, we started by, we had to simulate it a few times to make sure that it would actually work. What you have here is a schematic, a couple of voltage dividers driving some transistors, send it through a diode, which goes across an LC tank, which then, this is actually representative of the coil load that will end up actually transmitting our signal. This is the waveform of one of our simulations. It's about 2.5 megahertz, I think is what we calculated.
But in reality, it only oscillates around 1.2 megahertz.
So, what else? Oh yeah, the simulations, for whatever reason, aren't exactly indicative of what we ended up getting physically. And over the course of our designing our project, we ended up destroying at least 3 prototype circuits, including blowing a few transistors and the circuit board itself. And at one point, we tried using a motorcycle battery to get enough current, but that contributed to destroying one of the circuits.
Okay. Basically, our transmitter consists of voltage dividers to drive these power transistors, which these are on top of these we have actual real heat sinks. We tried to use little metal plates, but they wound up heating up. And so anyway, so then these transistors send a voltage to the inductors. Switch the oscillations caused by the power imbalance, which we actually had to. The power imbalance. We needed a power imbalance to cause the power transistors to actually oscillate. We originally tried unbalancing our voltage dividers to hopefully create and start oscillations. However, that didn't work, and that actually just wound up heating up one transistor more than the other, and that one would explode first. So actually, John Kazana came up with the idea of basically tapping the power supply a couple of times before you would actually connect the circuit, which enabled the circuit to oscillate and therefore us to transmit power. Basically, we used for the coils, we were originally going to use helical antennas, and we derived equations for that, but the size of the antennas we'd need weren't feasible. We were looking at 5-meter long antennas at 0.3 meter diameters, and that just wouldn't work. So we settled for matched single turn antennas, and pretty much we used for the transmitters, being that this circuit oscillates at 1.2 megahertz, we used a pipe to account for the skin effect, because if it was a solid wire, all the copper inside the pipe would just heat up. And basically, that transmits to our coil, which is just a wire here, to its LC tank circuit. We tried different values. We originally tested it with the capacitance. We weren't getting such great results, and then we realized we're getting about as good results without any capacitor at all connected to the tank circuit. Then we played with a number of fixed capacitors to find capacitance which worked for us, which enabled us to get around 33% more distance in power transmission. Our overall our circuit at maybe 1 or 2 inches gains, it gets about 40% efficiency. Actually, there's one more point. Oh, we were originally going to power an actual flashlight. We tried to wire it in, and then there was a spring within the flashlight which acted as an inductor, and being that we were transmitting at 1.2 megahertz became just a giant impedance in our circuit and caused the circuit not to work and frustrated us greatly. Bill?
I'll talk about the future potentials of the project. We really wanted to get it to the house stage, and we actually researched many different types of charging circuits. Basically, just the regulator that would regulate the AC that we have to charge whatever battery we wanted. We wanted to use it with a razor, but we hit so many snags in just getting it to oscillate that it was pretty. We didn't have enough time to actually reach the full potential of the initial goal of the project. According to MIT, they got a research study that said that the more coils that you have, the more increased efficiency you find. So that was another little added motive to the whole powerhouse, like the wireless house, because the more coils you have around you, the more efficient you're at. We went through many transistors. We blew an entire shipment of transistors. We had to order another shipment of transistors. And thankfully, John came up with the idea that you should tap the output of the power supply. For some reason, it was a snag that we really hit. Because whenever we would power this power supply,